With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. In the diagram shown, the coefficient of friction between 2 kg and 4 kg is given here. Between 4 kg and the ground is 0.2. Answer the following question. At t equals to 4, the friction between 4 kg block and the ground will be. So at t equals to 4, what will be the force? The force is 2t. So at t equals to 4, the force will be 2 into 4, that is 8 Newton. 8 Newton will be the force. Now let's check the limiting friction at the two surfaces, right? If you see the 2 kg block, on the 2 kg block in upward direction, the normal reaction will be balanced by the weight in downward direction, that is 20 Newton. So I will write the normal reaction is equals to 20 Newton. And on the 2 block, if you see here, on the 2 block, the 2 block system, the normal reaction will be, let's say I say this N1 and this is N2. So I will write it will be equals to this. As you got the normal reaction, you can also calculate the limiting friction. It will be mu1 times of N1. Mu1 you can see it is 0.1 and 1 is this. So 0.1 into 20 it will be 2 Newton. 0.1 is the mu1 and 0.2 is the mu2. Now let's find out the limiting friction at the surface 2. Mu2 into N2. Mu2 is 0.2 if you see here, and here it is this. So 0.2 into this, it will be 12 Newton. So we got the limiting friction at the two surfaces, right? And if you see here, right, the force applied is equals to 8 Newton, right? So 8 Newton is the force applied and limiting friction is this, right? So when it will tries to move, this force is more than the limiting friction force. So it will move, right? It will move, right? Now let's check how it will move. If you see here, let's say it start to move, then what will happen? First of all, in this surface, limiting friction, at this surface, the limiting friction only will act, right, at this surface. And yes, this surface, the limiting friction will act. And here the force is 8 Newton is acting. And since, if you see the motion is there, so tension will be here, non-zero tension will be here, right? So it will be F1 T, and this block is 2 kg. And if you see, on this also the tension force is acting like this. And yes, if I say this block is moving, this upper block is moving, then this block will also move, right? But we don't know whether here the limiting friction force will act or what will happen, right? For that we have to check the condition. How? Let's see how we'll check it. If you see, first of all, we already know here the limiting friction will act, right? And the force applied is 8 Newton. And limiting friction here, it is equal to 2 Newton. And the tension you can calculate, right? If you see here, we are checking the condition. We took case 1 that system is at rest. There is no relative motion. So for that, let us see whether the condition is being fulfilled. The required friction is less than the available friction or not. For that, I am saying for that, the tension force here, if I say this is not moving, will be this. And it will be equals to 6 Newton. So if I say the system is not moving, then the tension force would be equal to this 6 Newton. And let's check what is the friction force required here for this. So I am saying the tension here is this, and if I say this block is not moving, this 4 kg block is not moving, let's check. We are just taking a condition. So I will write this. From here I will get the required friction is equals to 6 Newton. And if you see the available friction here, available friction, it is this. Available friction is 12, requirement is 6, right? So the case 1 is valid. System will not move because here the requirement is less than the availability, right? Availability is more. So the system will not move. Now you can just write down the values. So here I will write 6 Newton, as we have already calculated, it is 6 Newton, and this is also 6 Newton. Now if you check for the option, so we want the friction force between the 4 kg and the ground. So if you see the 4 kg and the ground, it is. Now here you can see the applied force is more than the limiting force at the surface 1. This is surface 1. And here the friction force is 2 Newton and the force is 8 Newton, right? Now if you see here, if I take case 1 is system is at rest. There is no relative motion. There is no relative motion. So I will write the FBD on this. Let's say here the force is acting. Here the force 8 Newton is acting, right? And if you see here, the limiting friction is will act here because the force applied is more than the limiting friction. Tension force will act here, right? Now let us do step by step. So here the force we have seen, it is 8 Newton. So limiting friction will act and it is 2 Newton. If you see at the surface 1, the limiting friction is acting and it is 2 Newton. And case 1 we took that the system is not moving and we are checking whether the requirement is being fulfilled or not. So if I say the tension, you can calculate the tension, it will be F minus F1. That is 8 minus 2, that is 6 Newton. So here the tension will be 6 Newton. So here the F1 will also act, right? And here let's say the F dash is acting and we are checking whether the F dash is less than or more than what is the value of F dash than the limiting friction, right? So if you see, we got the value of F dash, it is 2 Newton, and we got the tension value, right? So we can write down the F dash is equals to T minus F1. So it is 6 minus 2, that is 4 Newton. Okay, and what is the maximum available friction? If you see, the maximum available friction here is 12 Newton, but what we want to stop the motion, it is this. This is 4 Newton. So F dash is less than F2. So the system will be at rest. There will not be any relative motion. Condition is being fulfilled. There will not be any relative motion. So what will happen here? The relative motion tendency will rises here. The tendency of the relative motion will be there, but this limiting friction will try to stop it, and then tension will generate, and the equal amount of tension will act on this block also, and here the same tension force will act, and this will also have a tendency to move rightward, and here the friction force will generate, and they will adjust the value like this, and finally the system will be at rest. So you can see the F dash value, it is 4 Newton and it is directed toward left, right? Toward left 4 Newton. So you can see B is the correct option. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.